Hello everyone, I'm Dr. Rajesh and I welcome you in this video lecture. In this video lecture, we will study nth order derivative of the following two questions. So one is find nth order derivative of 1 by x square plus 5x plus 6. Then we will find nth order derivative of x raised to the power 4 divided by x minus 1 into x minus 2. So these questions we will be solving with the help of partial fraction. With the help of a partial fraction. So now here we will try to attempt question number 1. Say this is y is equal to 1 by x square plus 5x plus 6. So here you see this can be factorized as 1 by x square plus 3x plus 2x plus 6. So it is further equal to x plus 3 plus 2 x plus 3. So this is equal to 1 by x plus 2 x plus 3. We don't have the formula to find nth order derivative when there is product of two linear terms. So here instead of this, if it would have been only 1 by x plus 2 or 1 by x plus 3, we could have easily determined their nth order derivative with the help of the formula y is equal to 1 by ax plus b. How will you find its nth order derivative? You will differentiate one time. It will be minus 1 ax plus b. Now you can easily find, and in examination you will also show this calculation that I am doing to find the derivative 1 by ax plus b. This will be minus 1 minus 2 into a square divided by ax plus b raised to the power 3. So this will be, and I have already, it will be minus 1 raised to the power 2, here is 2, so in the end it will be minus 1 raised to the power, and 1 into 2 is 2 factorial, here is 2, so in the end it will be n factorial. It is a square and here is 2, so it will be a raised to the power n divided by ax plus b raised to the power n plus 1. So this is the nth order derivative of this one, but here is neither 1 by x plus 2 or 1 by x. This is the product of x plus 2 and x plus 3 in the denominator, but with the help of partial fraction I can separate them as 1 by x plus 2 or 1 by x plus 3. So I will be using partial fraction and will partial fract this thing. So this is a by x plus 2 b by x plus 3. So here you will compare 1 by x plus 2 x plus 3 is equal to a x plus 2. So this will cancel out. 1 by x plus 3 is equal to a. Fine. So put here x is equal to minus 2. So put here x is equal to minus 2. This will imply minus 2 plus 3 will be plus 1. So a will be 1. Now compare this one with this one. It will be 1 by x plus 2 x plus 3 is equal to b x plus 3. This will cancel out. Put x is equal to minus 3. It will be minus 3 plus 2 is equal to b. B is equal to minus 1. So here I am going to substitute these values. A is equal to 1, it will be x plus 2, it will be minus 1, x plus 3. Now this is equal to y, so y is equal to 1 by x plus 2, 1 by x plus 3. So we need to determine their nth order derivative. So their nth order derivative, say yn is equal to dn by dxn, means nth order derivative of 1 by x plus 2, nth order derivative of 1 by x plus 3. So this will be, here this is same, here a is 1 and b is 2. So use this derivative formula. Minus 1 raised to the power n will be same, n factorial will be same, a is 1, so 1 raised to the power n divided by a is 1 and b is 2, so this will be x plus 2 raised to the power n plus 1, minus here a is 1 and b is 3, so it will be minus 1 raised to the power n into n factorial into a, here a is 1 divided by a is 1 and b is 3, so this will be x plus 3 raised to the power n plus 1. So this thing both are common in both, minus 1 raised to the power n into n factorial 1 by x plus 2 raised to the power n plus 1 minus 1 by x plus 3 raised to the power n plus 1. This is yn, and this is the required nth order derivative of this given function. So in this we have used the partial fraction so as to separate the two linear terms and written them as sum of 1 by x plus 2 minus 1 by x plus 3. We did it because we only know the nth order derivative of the function of the form 1 by ax plus b, but we didn't have any formula when the linear terms are in the product. So we have done the partial fraction, and we have studied partial fraction in 10 plus 2. So utilize that knowledge and partial fract, and then differentiated it n times and use this particular formula. So this is the solution of the first problem. Now I will take up the second problem and we'll see how we'll solve it. So I will be taking the second problem. So here is the second question, that is, say this is y is equal to x4 divided by x minus 1 x minus 2. Here one thing that will come in our mind is that use the partial fraction over here, but before using the partial fraction we should make sure that degree of the numerator is less than the degree of the denominator. Here the degree of the this has degree 1, this has degree 1, so when they will be multiplied the product will be have degree 2. So here we have degree 2 and the numerator has degree 4, so degree of the numerator is greater than the degree of the denominator. So we cannot apply the partial fraction upon it in the present form, because to apply the partial fraction the degree of the numerator has to be less than the degree of the denominator. So in this case we have no option but to carry out the division. So I will be carrying out the long division. So when you multiply x4, when you will multiply them, it will be x square minus 3x plus 2. So I am going to divide x4 with x square minus 3x plus 2. So it will go upon x square, multiply it with x square, it will be x4 minus 3 x cube plus 2 x square. So this will be minus plus minus this will cancel out 3 x cube minus 2 x square. This will be plus 3x. So you will multiply 3x. So what you will get? 3x cube minus 9 x square plus 6x. Minus, it will be plus, it will be minus. This will cancel out. So you are left with 7x square minus 6x. Now it will go upon, it is x square. So it will go upon 7. So now you will multiply this with 7. It will be 7x square minus 21x plus 14. So this will be minus, this will be plus, this will be minus. This will cancel out. It will be 15x minus 14. So you know that you can write this as this quotient as such, x square plus 3x plus 7 plus 15, the remainder, and the factor with which we are dividing, it is x square minus 3x plus 2, which will be further equal to x square plus 3x plus 7 plus 15 x minus 14, and you will make the factors. It will be x minus 1, x minus 2. Fine. So now this is the long division that I have carried out. Now I am going to remove it so that I could get some space over here. So here we are. Now you see the degree of the numerator is 1 and in the denominator it is 2. So now this thing can be partially fract. So we can write it as x square plus 3x plus 7 plus a by x minus 1 plus b by x minus 2. So what will be a and b will be determining. So here I am writing 15 x minus 14 x minus 1 x minus 2 is equal to a by x minus 1 b by x minus 2. Now this will be written as 15x minus 14 x minus 1 x minus 2 is equal to a by x minus 1. X minus 1 to x minus 1 will cancel out, and here you will put x is equal to 1, the thing that is in the denominator to the a. So x is equal to 1, put it over here. 15 into 1 is 15, 15 minus 14 is 1, 1 minus 2 is minus 1 is equal to a, implies a is equal to minus 1. Fine. Now here compare this one, 14 by x minus 1 for value of b, x minus 2 is equal to b by x minus 2. This will cancel out. Now put x is equal to 2 over here, the thing that is in the denominator to b. So it will be 15 into 2 is 13, minus 14 will be 16, and 2 minus 1 is 1. So this implies b is equal to 16. So I am going to put it over here, x square plus 3x plus 7 minus 1 by x minus 1 plus 16 x minus 2. Once again you will be writing the differentiation of ax plus b, nth order, and we don't need to remember, you will just carry out, and in the earlier part I have done it a raised to the power n by ax plus b raised to the power n plus 1. Now you see here, this x square will vanish after second order derivative. In third order derivative this will not appear. So this could not be the part of the generalization because it is not going till the nth order derivative, means a derivative of any order, let's say 1 million times derivative, it will not appear. It will not be part of the generalization. So we will, whatever the answer we will get, we will be putting the condition that this generalization is for n greater than 2. So these terms will not be appearing in any derivative after second order derivative. So I am going to write yn is equal to, write this nth order derivative of this one minus, as such it will be minus 1 raised to the power n into n factorial into 1 raised to the power n by x minus 1 raised to the power n plus 1 plus 16 into minus 1 raised to the power n into n factorial into 1 raised to the power n x minus 2 raised to the power n plus 1. Fine. So here you will take minus 1 raised to the power n factorial common. So this will be minus 1 by x minus 1 raised to the power n plus 1 plus 16 x minus 2 n plus 1. So here you will also put n greater than 2. The reason is very much clear that after second order derivative this term will vanish away, so they will not be present in the nth order derivative, that is a derivative greater than 2. So here I have used the condition n greater than 2. So in this video lecture we have studied two important problems, and in this problem we have firstly checked the degree of the denominator and numerator, and the degree of the numerator should be less than the degree of the denominator, then we have partially fract. But here the degree of the numerator was greater than the degree of the denominator, then we carry out the long division and express it in this term and use the partial fraction for this term. And here the condition that appeared is n greater than 2 because this term will vanish away after second order derivative. So these are the two questions. These are the two questions that I have taken to illustrate how to carry out the nth order derivative calculations with the help of the partial fraction. So that is all I have from this lecture. And if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.